Hi, I'm Scott Campbell, Sales Manager of Fiberglass Developments. I've tried to capture on videotape both a technique for working with fiberglass materials and a fun project which can be modified or copied to suit your taste. If you bought the tape so you can duplicate the roadster trunk onto the back of your own project car, sit back and enjoy the demonstration. I have provided a materials list and expect the video to explain all the instructions. If you bought the tape to learn about the moldless composite technique, please realize that it is not limited to this project. The fundamentals shown here can be applied to virtually any structure, including airplanes, boats, household items, as well as cars. We started the project for an extensive fiberglass repair article in Kit Car magazine. As you can see from these pictures, more of the body was actually missing than was present. The car owner, Rob Holmes, had purchased the body at a swap meet for $25, not really knowing what to do with it. I enlisted his help in the reconstruction.
Hi, I'm Rob Holmes, the proud owner of this new Roadster. Before meeting Scott, the T-bucket hung in my garage for nearly 2 years. I didn't know how to fix it or where to get the materials. I was just getting ready to throw it out, and Scott came up with the idea to be perfect for a restoration project.
We began by repairing the firewall and floor to help regain the shape of the body. We actually sectioned 3 inches from the bottom of the bucket just to get the floor square. Next, we started patching in holes everywhere else. Mostly we used fiberglass mat, resin, and masking tape to put it back together. The last stage was to fix it cosmetically. We took out the door seams and used body filler to straighten everything else. After the mud was in place, we sealed it in Duratec. The Duratec surfacing primer fills, protects, and hides everything below it. It's sprayed evenly too. Rob was happy enough with the progress of the body to start building a frame for the car. That's when we realized that we were onto something. I knew I could build a one-off copy of the early Roadster trunk onto the back of the T-bucket instead of running the short truck bed like everybody else. I also knew it was time to let the moldless secret out of the bag. What follows is a thorough documentation of the moldless composite technique. Moldless composite construction is the process through which a functional composite part is built in the first production cycle without the time and expense needed to generate a female cavity mold. It can more accurately be called internally molded construction, as a form does need to be made, but this form is covered by reinforcement and often stays with the final part. Moldless construction offers numerous advantages to both experienced and moderately skilled builders. Most notable is the ease with which complex shapes and contours can be created compared to metalworking. With simple tools, the proper materials, and knowledge of the 6 steps of moldless construction, durable structures can be made which will withstand years of rigorous use. Since I already had half the car body and wanted the first trunk to be functional, moldless construction was really the only option. Individually, the 6 basic steps of moldless construction are design, construction of internal form, shaping of internal form, reinforcement of internal form, modification of form and bonding of subcomponents, and cosmetic finishing. I designed the trunk from photos in Street Rodder and Rod & Custom magazines. Both Rob and I wanted to achieve a nostalgic look, so we turned to some shots of vintage racing cars at the Bonneville Salt Flats in the 50s. To determine the scale of the cars pictured, we measured their wheels. We knew that the wire wheels were often 16 inches, so we converted the rest of the dimensions to full scale accordingly. This gave us a good starting point that you will see us translate to the cardboard templates we use in the construction process. We made some custom changes to suit our taste, but basically developed a 50s period Roadster. The material selection took a little more forethought. I knew that I wanted to use a sandwich core of polyurethane foam between layers of fiberglass cloth. I felt the stiffness advantage would give us a trunk which would be sturdy and still lightweight. Polyurethane foam is easy to sculpt and resists moisture and fuels. The only legitimate concern with this technique is that you can lose a little space on the inside of the trunk due to the thickness of the foam. I addressed this in 2 ways. First, I selected a thin 1-inch foam for the top of the trunk so I maintain the largest space possible. Second, I shaved some foam from the inside to reduce the thickness after the outside had been reinforced. The rest of the materials were selected for compatibility and durability. General purpose polyester resin was used with the saturated fiberglass cloth. This combination was inexpensive, user-friendly, and strong enough to absorb the shocks of everyday driving. What little wood was present in the trunk was sealed within the materials for protection. The final coating of Duratec surfacing primer was also polyester-based, so it will adhere well and hide everything below it. This is important because when the car heats up in the sun, nothing will move or shrink, ruining the final paint job. Construction of the internal form began by screwing 2x4s to the bottom of the T-bucket. These were used as supports and alignment guides to keep everything to come later lined up with the existing floor. The first place I'm going to start is developing the contour here on the back of the T-bucket itself onto the cardboard. What I'm going to do is make a measurement to see how deep the cardboard is actually going to go into, and that will be the same distance that I'll subtract off the cardboard at the top, and that way we'll develop the curve and be able to cut that out. That's the first dimension I'm shooting for. By scaling up the magazine picture, I was also able to plot points which define the outer shape of the trunk. We've worked up the contour pretty well. We're now going to go along and finish up what we want on the shape of the back of it, and then we'll make one for the other side as well. Using this flexible drafting tool, we're connecting all the lines that we put on here to make one uniform contour across the back. The tool's real nice, it'll bend to any kind of contour that you want. And then along the rear here, why don't you grab the wheel, we wanted to have the same radius as the rear tire. So we've taken a 15-inch wheel and filled that in, and we'll simply trace around that as well. I'm going to take a razor knife. This seems to work a lot better than the scissors for giving you an accurate cut through the cardboard. Again, this is going to be the final shape of the vehicle. Accuracy at this point, this is where you need to spend your time. The rest of the technique that we'll show you with the fiberglass, all it develops from what we're doing here. This is where to spend your time. Don't think that you're going to make up for a wrong shape later. We've got the final shape here. I trimmed it all out with a razor knife, and it looks real good. It fits well up against the body, and it's going to have a real nice contour. What we're going to do is we're going to trace this on another piece of cardboard and fine-tune anything between the two sides, and then we'll cut out the plywood templates, which will be the form for the whole shape that will be taking place later. Actual plywood construction begins with the floor. I took measurements along the length and the entire width. I then subtracted 2.5 inches from each side of the trunk to determine the final width of the plywood floor. The line was drawn on the plywood, and the circular saw makes quick work of the cut. The floor was then screwed into place. Tracing the cardboard shape onto the plywood. All these are very simple procedures. We'll just cut that out with a jigsaw. I've begun the cut. Notice that I leave the straight edge of the plywood as the bottom edge of the form. This ensures it will sit squarely on the 2x4 braces, and the jigsaw is used only for cutting the upper contour. There's the first piece. Note that it might be a little bit rough, and I saved the line, but it's important that we screw the two pieces together, and we'll shave it all down to the identical size. And so I'm not too worried about the way it looks right now. Put that in place, and we've got the first look of what it's starting to shape up like. I'm using a square to make sure that the bottom edges, which are the uncut portions of the plywood, are lined up. And I'm going to clamp the two halves together. And in this way, I can shape the upper edge and make sure that they're identical without anything moving. I'm going to proceed to a sanding stage where I level this off and make sure that this is square as well. It's far better to spend more time at this stage right now than to go back and think you can replace low spots with body fillers or extra fiberglass or anything like that. You want to make sure these are identical, because the next stage will be drawing a large sanding block across it to create the shape in the foam. And again, I'd rather spend an hour doing this than 3 or 4 hours filling and sanding and doing things in the final bodywork. The key element here is to make sure that both halves are identical. So I'm going to use a hand file and take down any high or low spots and even it all out. The whole time ensuring that everything is square and that one side is lower than the other. I've got a belt sander. I'm going to switch to that real quick, but the file will work. As you approach the final shape, be sure to pause frequently to check that everything is still square. I recommend switching to a hand sanding block to get the wood just perfect before mounting. Put that in place, and we've got the first look at what it's going to start to shape up like.
I drilled a pilot hole through the fiberglass so I wouldn't splinter it. Now I'm just going to take a drywall screw and run it through the hole to begin lining up.
I'll continue mounting the plywood framework to the bucket, and then move on and screw the lower edge of the sides to the floorboard. This will provide enough support that we can move on and begin filling the open span with foam.
Side's looking pretty good.
I begin by measuring the width along the top of the trunk. I'll transfer that dimension to the 1-inch polyurethane foam and mark a line with a straight edge.
I'm using a sharp break-off knife. It'll be at least 1 inch thick. Cutting right along the straight edge through the foam.
At the end of the cut, the foam will break off, much like a piece of drywall.
Okay, we've got the foam cut to the width that we need. I'm going to spread wood glue along the inside of the wood only because I don't want to get the glue higher than the foam. When I go to sand it, the dry glue will sand much more difficultly, and as a result, you can have higher low spots in the foam while the sandpaper was working on the glue.
A uniform wet coat along the top edge is all that is necessary before laying the foam in place.
As you set the foam in place, make sure you keep it high, above the contour of the plywood. Because what you're going to do is use the long sanding block to sand it true and even with the plywood.
I used a long pipe clamp to snug the sides up against the foam.
The foam is flexible enough to assume some of the contour on its own. Okay, I'm going to cut the foam at a slight angle so it can be mitered with the one that follows.
As Rob finishes the cut, the foam breaks cleanly away.
I'm using the sanding block actually to miter the corners so that they fit and everything butts up, okay? And then I just piece it in place and check the angle of the joint. Right now I've got to do a little more. Basically, you just keep cutting and piecing pieces in place until you got the full shape filled in.
More glue on the joint is necessary before the foam can be put in place. A great advantage of the polyurethane foam is the ease with which simple tools make it workable. Toothpicks are being used to keep the foam from separating while the glue dries. These are easy to insert along the bond line and will leave no trace after they are removed. The lower piece of foam has been prepared in a similar fashion and easily slides into place. Toothpicks are used again to maintain the foam contour across the entire 36-inch span. The pipe clamp is used while the glue dries. The foam can bow easily, so don't use too much pressure. Make any final adjustments at this time, ensuring that the foam is higher than the plywood in all areas.
While we're waiting for the glue to dry and the whole rear section to take shape, we're going to start cutting in the 2-inch wide pieces that we're using for the sides. The main contour that we're going to get right on the money will be around with the T-bucket, and we're going to leave everything else high. Again, we'll sand down to the plywood, which will give us perfect contour from the 2-inch all the way across the flat surface, and then the other radius as well. I'm tracing the cardboard template that I used for the plywood onto the 2-inch foam. This is going to be an accurate copy here, but when you go to cut it out, be sure to cut it larger again, because we're going to sand it down to the same size as the plywood.
I'm using a long adjustable razor knife to cut through the 2-inch foam sheet. Try to make the cut in one pass for a smoother edge. If the foam is cut completely, it will break freely away from the rest of the sheet.
We're fitting the side pieces in place. I was working this by trial and error to make sure that the contour matches the rear of the bucket exactly. He's got some good experience with this type of work. However, it's the same as anyone else can do it. You just take off little bits at a time until it fits and matches up perfectly. I was applying a good even coat of the glue. There's really no such thing as too much. At this point, again, you just don't want it anywhere near the edges where you're going to have to sand the high spots. So we've got quite a bit on there. We've already sanded everything to fit. I'm kind of sliding it all into place. Help the glue even out. And firm pressure is all it takes to make it stick. Okay? And when the glue dries, we'll just sand it with the rest of it all to contour.
After the glue dries, the toothpicks must be removed so they don't obstruct the sanding operations.
They were there just long enough to hold the shape. This one seems like it's glued in. Okay.
I am doing some preliminary trimming on the edges using the razor knife. The sanding goes quickly, but any large pieces you can remove with the knife will speed things up. Do not try this in the large, broad center section.
You've heard me allude to the sanding blocks throughout the whole process so far, and now I'm actually at the point where I need to use them. And I might as well show you how I made them. This was nothing more than a 1x4 that I ripped lengthwise so it would be the same width as the sandpaper. I then I made it a little bit longer, wider, so I could have some extra room to go side to side on the back. And then just screwed the leftover portion of the board with drywall screws and a little bit of glue to it. It's a perfectly flat surface. I picked through about 40 boards until I found the one I was actually going to use. Again, I don't want to have anything off or anything. That's going to be my truing surface. The second sanding block I made was just a standard, it was a 2x6, and I just took a compass with a 2-inch radius and drew that onto the board. And this is the one I'm going to use to shape the edge contours after I've already got all the rest of the foam to the shape that I'm looking for.
As I begin to sand, notice that I use only a side-to-side motion. Keep the block level and work all the way across the trunk. Do not lift one side of the block to concentrate the sanding on one spot, as this will distort the contour. Position yourself wherever necessary to keep the block true. If you choose to run the block front to back, be sure both sides of the block progress absolutely evenly. When sanding the glue joints, focus the effort on the glue itself. Do not try to tip the block into the foam and gouge it. Move periodically to remove the glue dust, as this can cut away at the foam as well. Soon the foam will be sanded flush with the plywood. You will feel the sanding block vibrate more as it tries to sand the template. Stop soon after reaching this point, as further sanding will just erode the foam near the wood, creating low spots. This occurs because foam dust trapped under the block tends to accumulate by the template and is abrasive enough itself to continue sanding in those areas. When the top is done, use the radius sanding block to shape the sides of the trunk. Work carefully, keeping the block flat, as it is very easy to gouge the surrounding foam. Continue sanding the edge until the radius block hits the plywood. Periodically check how the contour is progressing and stop when all the effort is just on the template. Drag a perfectly true steel rule evenly along the plywood looking for daylight. If there is no light, the foam is smooth and the sanding is complete.
Actually, what we've decided to do at this point is to French in or recess the license plate area. We were flipping through a magazine here, just killing time, and saw that it was done on a couple cars, and now is the perfect time to do it before there's any other fiberglass skin. The next thing I need to do is continue to cut out around the plate area, and I'm going to use a straight edge to make sure that everything works out just fine.
Cut all four sides this way. I'm fortunate to be able to get one hand behind the foam to press out the license plate. If access had been limited, I could have pried out the foam from the front, but it is easier to damage the foam that way.
While I was trimming it, the knife got away from me, and I have some small cuts on the back side, and so before I insert this and recess the license plate, I'm just going to put a little extra glue down inside there. So you can do quite a bit with the foam and still have it work okay for you. This will never be seen, it's just something that'll keep it from coming apart perhaps, or whatever within the trunk. And then I'm going to run a bead of glue along the entire inside. I've got glue uniformly all the way around the license plate. I'm just going to put it back in the hole. But as you can see in real time, 5 minutes or less, made a nice recessed license plate. Square. This will be mounted later. The shape has been totally developed in the foam at this stage, and so while it still remains real fragile, the next step is to reinforce them with a fiberglass fabric. I'm just going to use a regular general purpose polyester resin and the appropriate MUKP hardener. The fabric I'm going to use to reinforce it is a 10-ounce fiberglass fabric. I'm actually going to put down the schedule I'm going to use, 2 layers of the 10-ounce fabric followed by 1 layer of a 6-ounce fabric. The 6 ounce is used because the finer weave will be easier to fill with primers and other body fillers so that you don't see that printing through paint later on. If I haven't said it already, you might as well keep any template you've developed to this point because they come in handy later. I'm going to cut the fiberglass for the sides so that I don't waste material. I'm going to follow right along the template. And again, I'm going to cut it a little bit oversized because I'm going to have it overlap where it hangs around the contour and everything like that. But I'll use the actual template. The other one I'm going to keep is the license plate template because I'm going to actually make inlays when I go to put it in the car. And so I'll pre-cut some fabric. I'm going to work on the sides first, and then I'm going to drape 1 layer of the cloth straight down over the back of it, and you'll see that next.
Before applying any fabric, it is necessary to precondition the foam with a hot coat of resin. Since the foam can absorb resin, it is best to apply a heavy coat initially to fill the surface and to wet out any dust particles. Be sure the entire surface is covered before proceeding to apply any fabric. The tacky surface of the hot coat will help hold the fabric in place. Stretch the fabric across the entire surface to eliminate any wrinkles. Gentle pressure is all that is needed to get it to stick. Make sure the upper edge is stretched uniformly along the top contour. Brush on resin until the fabric is fully saturated. The fabric color will change from white to clear as the resin soaks in. Continue applying resin until all the cloth has been covered. Watch for small air bubbles which may develop within the weave of the fabric. These usually require more resin to remove. Hot coat the license plate hole, working resin into all the corners. Inlay the pre-cut fiberglass and begin applying the resin desaturated. Do not put fiberglass on the offset lip at this time. It will be reinforced later. Finish the wet out of the license plate area and then use any remaining resin to begin coating the trunk. Finish pre-coating the remaining foam in preparation for the first coat of 10-ounce fiberglass over the trunk. I've selected a 38-inch fabric width which just overlaps the sides. This reduces waste and eases application. Be sure to straighten the fabric once again to remove wrinkles. Wet out on the flat surfaces is straightforward. Just keep a keen eye out for air bubbles. However, corners can be a little tougher. I first wet out the fabric and try to stretch it as much as possible.
When the resin reaches this semi-firm stage, you can use a carpenter's knife, and I've already started this cut, to trim away the excess material. You have to do it when it's firm enough that you're not lifting the resin off of the foam, but yet you can't wait until it is so firm that it can't be cut.
I am sanding the edge of the overlapping fabric so a ridge does not develop in this area as I add more layers. I applied a light coat of resin over the side of the vehicle, and I'm now fitting the second layer of 10-ounce cloth. This is wet out in the conventional manner shown before. I'm now applying a layer of 6-ounce fabric directly over the 10-ounce layer. Since the 10-ounce fabric is still wet, I am able to use a squeegee to work some of the excess resin up into the 6-ounce material. Both sides are fully reinforced, but the trunk needs 2 more layers to complete the schedule. At this stage, the outside of the form has been thoroughly covered in 3 layers of fiberglass. It is time to begin modifying the part and reinforcing the inside as well.
I've marked off the trunk lid, just using measurements and a template and some things again out of a magazine to get the right proportions. I marked it off with a marker and made sure it was all squared up. I'm going to use a die grinder fitted with a cut-off wheel to just nip through the fiberglass itself, not go all the way through the foam. That's why I'm not using a jigsaw or anything else, because then I'm going to cut the foam smaller on the inside and actually leave a lip within the trunk like a modern car has, so it can be watertight. So I'm just using this just enough to cut through the fiberglass itself.
Heavy pressure can make the wheel jump offline, so begin lightly and cut straight. Take your time cutting openings in the fiberglass skin. Gouges in the foam can be fixed, but it is extremely difficult to replace miscut fiberglass in areas like trunks and door openings.
All right, I've made the cut all the way around with the cut-off wheel. I've now removed the Roadster back from the chassis because I'm going to need access to the inside of the trunk. I'm actually going to cut the lid, but what I'm trying to leave behind on the inside of the foam is a lip. And you'll see that in the finished product. This is a perfect look of the inside of the trunk, flipped upside down. I've marked out the trunk lid size 1 inch smaller on the inside than it was on the outside. I'm now going to take a razor knife, follow this straight edge, and make a cut through until the blade hits the fiberglass on the outside. I'll do that in all dimensions. We're actually trying to run a knife directly underneath the fiberglass to separate it from the foam. So it will leave urethane on the inside that we can file down to make a weather strip lip. Not everybody has to do this if you're making this part. It was one way we felt we could do that and make it a little more like a production part. So we're giving it a try. It seems to be working okay so far.
For this to work well, try to make the cut very shallow so the remaining foam is not hurt. However, if the foam is damaged, it can be replaced with new pieces.
Left with a trunk lid that we can reinforce. I need to take off all this urethane here and fix some of the urethane around the edges. But what we'll do is we'll reinforce over them, and we'll actually make a catch drip rail that will help waterproof the trunk. The inside of the trunk lid is now reinforced as well. Please note that the foam was filed at about a 45-degree angle, just sanded down, so that no air pockets would fit or form around the foam, the perimeter of the foam. Air tends to form anywhere where there's a 90-degree angle, and so I recommend that you bevel all edges of foam or whatever sandwich core that you're using, just so that you get the best bond possible. The fabric then has a nice the ability to make just a nice gentle contour over the up and down areas of the foam. But this thing is amazingly stiff and very light, and I'll trim it up and it'll all fit in place. At this point I'm modifying the trunk lip. What I tried yesterday didn't work out so well, so I'm actually just replacing the foam. And this is working real slick, so I thought I'd show it. Just breaking off pieces. I'll sand them on my sanding block. Put the knife down. And I'll glue them before I get them finally into place. but it just right back into place, and there aren't too many materials that I know of that you could do a repair procedure quite so easily. My final preparation before putting a fiberglass skin on the inside of this whole trunk section is to radius this new edge that I've produced. Again, fiberglass doesn't go around 90-degree angles very well, so anywhere where you can bevel something, I highly recommend it. Obviously, this foam works very easily. Corners disappear in seconds.
The drip rail needs to be fully supported, so that means adding fiberglass reinforcement. I first tipped the trunk on its side so gravity would help hold the fabric in place. Next, I hot-coated the foam and plywood. I'm using pre-cut strips of 4-ounce fabric as the initial layers on the lip. 2 layers will actually be applied before any 10 ounce is added. A full-size piece of 10-ounce fabric is then added to cover the entire inner wall of the trunk. This will also drape over the drip rail to add extra strength and create a seamless inner appearance. When the entire housing has been skinned, I will make the final modification to make the trunk seal functional.
I'm now going to finish out the weather stripping seal or lip. I'm just going to cut and trim away the foam, running a razor knife right along the edge of the trunk opening itself. Just using a chisel now to remove the material in large sections. It's coming out easily without damaging the good foam along the side here. What I'll have to do is go along and re-skin that with fiberglass on the inside so there is no exposed foam, but it's creating the exact cavity that I was hoping for.
I'm skinning using 4-ounce again. 2 layers are all that are necessary to keep out the elements. Notice that I switched to a 1-inch brush due to the narrow working space. I trimmed this lip with a razor knife, but I still need to sand it. Actually, I'm sanding off a 1/4 inch so the trunk will still close with the rubber seal in place.
I'm now going to prepare the surface, the back of the T-bucket for bonding the roadster back to it. I've marked a line that's about 2 inches beyond where the tail section fits in. And I'm going to just mechanically abrade it. I've got 80 grit sandpaper on the back of this. I'm going to grind it down. I'm going to valley out a taper slightly. It's going to be deeper toward the roadster section. As it fans out into the body, it will become shallower. And again, I'm just wearing good safety equipment.
Although it is 90 degrees, I still find it more comfortable to be completely covered during grinding. I'm not that sensitive to the dust, but I prevent exposure wherever I can. People who are extremely sensitive can apply baby powder to their skin. This makes grinding more comfortable. The belt sander cuts into the surface quickly. It removes surface contaminants and leaves behind large 80 grit scratches for the bonding resin to adhere to. I've begun by gouging deeply into the bucket near where the trunk will attach. As I move to the edges, my cut becomes shallower. This is referred to as scarf sanding and will later permit me to add extra fiberglass material to the joint on the outside of the bucket without creating a bulge. Along the top of the bucket, I am just removing enough material to expose a good bonding surface. The entire back of the bucket will look like this before I am finished. As you can see, my grinding was thorough. I actually extended my taper 4 inches from the bonding site in order to get a smooth transition later. Consider this the minimum surface preparation before any fiberglass bonding application.
I'm now going to mix batches of milled glass fiber. It's a putty filler resin. It's got some structural strength due to the fiber in it. Mixing a half pint with 5 cc's. It's a little hotter than usual, but the filler content will actually distribute or diffuse some of the hardening agent, and you need a little bit more. Notice I mix the resin and the hardener together first before I begin to fill it with the, this is 1/32 milled glass fiber. Takes quite a bit to fill this.
I recommend using a squeegee because it can quickly apply the adhesive to the site and spread it. Leave extra material in any deep holes in the foam. It will be squeezed out later. Spread the adhesive over the entire surface to be bonded.
I'm working in with pretty firm pressure. So it'll bond well with the hot coated foam, the plywood.
We slid the new trunk up against the bucket, aligned our marks to ensure the fit, and squeezed. The 2 parts make good contact, forcing out the excess adhesive. Working simultaneously, Rob is screwing drywall screws into the plywood templates for more clamping pressure, while I am creating fillets in the adhesive using a rounded end of a mixing stick. The first step to externally reinforcing the joint is to thoroughly wet out the bonding area. The first layer of reinforcement is 1.5 ounce chopped strand mat. I chose this because it promotes adhesion well in the scarfed areas, and the torn mat strips can form easily to the contours. After 2 layers of mat were on, we applied the first of 3 strips of 4 ounce fabric. The 4 ounce is nice because it is very flexible and quite dense. It's a good compromise for this area. A 1/2 by 3 inch groove saturation roller works well for compressing the patch and leveling the trunk. It is just the right diameter for forcing air out of the contour where the rear meets the bucket. More of the 4 ounce fabric strips are laid down the sides of the bucket and saturated. A gentle stippling action is all that is needed to work the resin into the delicate fabric. Notice how the fiberglass has filled the scarfed area, leaving a gentle, smooth transition between the 2 parts. The first step in cosmetic finishing is to sand the entire surface so the primers and fillers will stick. I'm using a dual action or DA sander with 80 grit paper to scuff the surface. When you get to the corners, the DA will tend to sand even quicker, so watch carefully that you don't cut too deeply through the fiberglass. Firm pressure is all that is necessary to get the desired results. This shot shows how well the entire surface has been sanded. The DA is great for leveling high spots, and as you can see, most of the surface is quite even. However, it won't be perfect at this stage because low spots still need to be filled. As expected, the area with the most fabric overlap required the heaviest filling. I'm using Z-Chrome body filler, which I have found to be the best on the market for workability and sanding.
I want to keep good firm pressure along the top of the squeegee, because that's the high spot, along the bottom of the squeegee at this point, because that's where I want to feather it in, and I want to leave all the material here in the middle. Now you can practice for years, but that's at least enough to perhaps get you started.
Begin leveling the filler using an air file board. The tool is convenient but not essential. A long wooden sanding block works just as well. The keys are to use long, even strokes and to focus on smoothing the high spots with the surrounding area. The dual action sander is needed to level the filler in tight areas. Once again, try to keep it level so the sanding remains uniform. The Z-Chrome sands easily and blends right in with the fiberglass. Rarely can everything be filled perfectly the first time. Sanding usually exposes areas that are wavy or just need more filler. Long skim coats can remove the final trouble spots.
Just finishing up the sanding. The last few contours here where it all meets the body. You can see everything's got a good overall surface finish, and I'm going to move on to priming with the Duratec surfacing primer.
The final step before priming is to wipe down the surface with a solvent to remove dust, waxes, and grease. Do not use a tack rag when using Duratec products. Acetone works best and can be applied with a clean towel. Be sure to open the rag when you are done so the acetone can evaporate before you throw it away. Duratec Surfacing Primer is a polyester-based primer sealer which is the best product available for covering and protecting fiberglass structures. It offers better protection than factory gel coats, yet sprays like paint. I'm using an inexpensive automotive spray gun and still have great control over the material. Siphon feed and HVLP spray equipment have controls which permit changing the shape of the spray pattern. I'm using a tight round pattern in the license plate area, then quickly switch to a broad fan pattern when covering the flat surfaces. Duratec's ability to be sprayed through this type of equipment without a loss in physical properties is what makes the moldless technique possible. Now it's time for a quick lesson in spray painting with this type of gun. Begin by holding the gun perpendicular and 10 to 14 inches away from the surface being covered. Depress the trigger and slowly move across the entire panel. Release the trigger briefly at the end of each pass to reduce unnecessary material buildup and overspray. Half of your spray pattern should overlap the previous pass for proper coverage when applying Duratec. If these steps are followed, satisfactory results can be achieved even by a novice. As you gain experience, the quality of your work will improve even more. Allow the first coat to tack up for 2 to 5 minutes before following with the second coat. The second coat is applied just like the first, but it can even go on heavier without sagging. It may not be easy to see the progression of your overlapping passes, so look for the glossy, wet line of your previous pass to be your guide. Following the third pass of Duratec, the material thickness is about 20 to 25 mils. You can see on this side of the car that the primer has filled the weave pattern of the fabric and completely sealed the body fillers underneath it. Since Duratec is from the same polyester family as the rest of the materials used to make the trunk, it will expand and contract at the same rate and forever hide the moldless internal form.
The roadster section is now all primed and filled with the Duratec surfacing primer. The 6-ounce fiberglass cloth, you can see a little bit of the weave apparent, but there aren't many materials that would have filled this heavily. Really what I'll be able to do is block sand and DA sand that down, and there won't be any texture left. We might have to do a little bit of minor filling and everything before the final paint work, but everything is bonded to the T-bucket. It's now a T Roadster, 1923. We're going to mount it to the chassis, and we're going to have a whole lot of fun driving it. Those are the 6 basic steps to moldless construction. The steps don't change regardless of the application. There may be fewer modifications to make or more bonding of individual units, but the principles remain the same regardless of the project you tackle. In the case of this Roadster, moldless construction permitted the quick and accurate duplication of the form while maintaining all the advantages of a composite molded part. The entire body weighs only 100 pounds and needs no steel reinforcement. It is corrosion resistant and waterproof as well. A functional trunk seal was also easily produced without cutting, forming, and welding sheet metal. It didn't require any expensive special tools. Overall construction time and costs were also quite low. It required just 50 hours to get the trunk to this stage right here. Go even faster if you're not making an instructional video. The total material cost was only $385, and judging from the comments we have gotten so far, it was well worth it. For those already familiar with composites, this project could be duplicated quite easily. If you're just beginning to work with fiberglass, though, I'd recommend starting with a scaled-down project. Fiberglass Developments offers a moldless composite kit, free technical assistance by phone, and other books and videos to help you begin to learn more. While the car is far from finished, Rob and I have had fun designing and building our own product. We are proud to have created a different look than the short truck bed or small turtle deck shape, and encourage others to do so if it suits your taste. We're not saying to forget about that heavily modified T-bucket look, but other options are possible using the moldless technique. I hope this video has been informative for anyone who has an idea they want to make happen. Before starting your next project, consider moldless construction. It's cheap and it doesn't take much time, and when it works out right, you can always make a mold. Until next time, I'm Scott Campbell saying, get creative and get busy.
Perfect.